actually, industries. That's what we wanted to ask. The PI system is used across industries. And so I have a question for you. Remember that poll I was asking you to go pull up on your phone, perhaps? Well, if you go to pollev.com/StuartC and respond, we can see your response. And I'd love to see like who is in the room right now. There's a lot of people here. What industry are you from? Now, I've listed out all the ones I could think of. I did not include in other categories. So if you're not included, I apologize for that. But we have most of those. So oil and gas, power transmission distribution, pharmaceuticals, the big one. Yeah. And this speaks to one of the things I'd like you to get first off about the PI system. One of the most fundamental things about the PI system is that OSIsoft sells one product to all these industries. It's the same bits. It's the same software that is downloaded by all these industries. We don't build a specialized product for each one. It applies to all of those. And as you can see, this room and this conference is full of people from across industries. Some are more than others, but they really represent a big cross-section. OK. So for one PI system, there's many, many uses. Besides being from many different industries, we find that it can be applied to about 6 different generalized categories. Again, these are generalizations. So the first one is quality tracking. So say you're a pharmaceutical company that's making like a drug, or you're making an aluminum rivet. And if you produce your product at the end, but it doesn't meet quality standards, you can't sell it. And you can't sell it. That's a loss for you. And you're really interested in, I want to be able to go back and track where in my process it went wrong so that I don't do that again. Can you help me with quality tracking? And people use the PI system for that.
And then another common use case is around energy use. So if I'm a data center or a large facility, I might not only be interested in looking at energy use going into my building or power use going into my building, but how is that power being used? Right? So in the case of a data center, can I track that power down to the individual servers that are using that power?
I might be interested in using it for asset health. Like I've bought this large turbine, and it costs many millions of dollars, and I would like for it to run for its entire lifetime and run well and not break unexpectedly. Can the PI system help me foresee anything that's coming on and maintain the health of that asset so I don't have any surprises down the line? And people use the PI system for that.
And then looking at process optimization. So how can I maximize my yield most efficiently? Right? And some of the talks coming up are going to go into some more details around that.
Yeah, so asset health is going to be covered more in depth in the session following this one, and process optimization is covered more in depth in the 3rd session in this track. Regulatory performance is another large category. This is where you're an industry that needs to make reports to the government, or you just need to make reports for whatever reason. And often that can be a long, manual, copy and paste intensive process. But people use the PI system to organize their data and make that reporting process as smooth as possible.
And then lastly, around safety and security. So if I owned a bunch of offshore wind turbines, it's often very expensive and also kind of dangerous to send maintenance crews out to fix these. Right? You have to send out a ship with some people on board to go fix the wind turbines. So if I can accurately predict when I'm about to have failure and send my crews out when the weather is calm, right? We're starting to do things a little bit more safely and securely.
Yeah. So this gives you a picture of what the PI system's used for. You've seen it's used across industries. What type of people actually use the PI system? So within an industry and a use case, I mean, there might be multiple people. For instance, maybe there's an asset, somebody specifically responsible for asset maintenance, and they want to know, okay, all that data is great, but I want to know the moment it starts going out of tune, and I want to be able to compare that to past times this has happened. Can your data infrastructure software do that?
And then looking at a control room technician whose main job responsibility is just to make sure things are always up and running. Right? So they're constantly keeping an eye on the data to just make sure they're producing quality product.
Yeah. Or you could be a production manager, and instead of being concerned with like what's going on right now, you're more concerned with, well, what's the forecast of productivity? How did it go in the last couple shifts? Like you have a different scope of what you're looking at. And all of those are important, but remember, they're all different users who have different needs. And the PI system works to deliver data in the way they need, the way they want it. All right. So what we said so far is kind of who uses the PI system, what it's used for. Now, let's take a step back and look at where does the PI system sit in the greater technological landscape. PI system is operation software. All right, let me tell you a little bit about what I mean by that. So let's imagine, let's simplify the world down a little bit, Clark, and say there are 3 types of enterprise-level software in the world. The first type is sales and marketing software. This is software that you use to sell your product, to market your product. It's your customer relationship management database. It's your sales force. It's your marketing automation engine. It's your website. It runs things that are very essential for you to sell and market whatever it is that your business is. And that's a very important type of software. Then there's a different type of software, which is your core business systems and your IT software. This is like your HR database, your accounting system, your warehouse inventory system. How you process orders often happens over here, and things that are specific to your industry specifically. And that's a very important, we're very familiar with that type of software. And then a third section of software is operations software. So operations software is, if you're going to sell something and you need to make it, this is the software that helps you do the making of the stuff. It's concerned with the processes that are making your fluids. It's concerned with the machines that are running to produce it. It's the mechanical labor that's happens with operations software. And it is another important corner of types of software out there. And it's distinct from the other 2. I think, let's see here. And the PI system appears right here. It's a type of operations software. I think most of the world is familiar with things that appear in the other 2 categories, really. Like those are the ones that you see on billboards, you see marketed, and otherwise. I don't see operations software marketed in the same way as much, so there's less popular awareness in the world of what operations software is. But it exists, it's a big market, and the PI system is a type of software that sits there. So I say this because often people are like, oh, I don't even know what it does and doesn't do. Well, that's the corner that it sits in, and it specializes in. That's not to say that it's not, it can't export data to the other sectors, but it's designed around the uses and the users that appear in the operations space. Now, okay, I lied. There's 3 types, but there's one that's kind of up and coming right now, and that's big data aggregation software. A 4th type that is designed around, let's bring together this data, and now we can ask questions we weren't able to ask before. Like maybe we want to compare some of our sales data with the production and weather data we have from operations and combine it with something from accounting or our enterprise resource planning system in the core systems. And I can now ask and answer new questions with big data or machine learning and cloud stuff. It's all very exciting. But one thing you get is that is as answering new questions, but all the old questions that you're still asking about, how do I maintain my assets? How do I have my production go well? Or how do I sell things? That's still very much handled by that specialized software. Okay, operational data that exists that's from that top area is actually quite a bit different than the other zones. So sales and marketing software, if I were to say there's a prevalent data type for sales and marketing software, it exists in networks and tables. So I'm talking about like a social network, who's linked to who. That's very important if you're going to be selling. Relationships are very important to that. Marketing, same thing there. Tables of data. You want to have a table with like a customer and different information about them and a sale that happened. And then you have another row for another customer. Data is stored in tables, and it's done in, it's a very appropriate way to store it. Core systems and business and IT software, really familiar with tabular and relational data. Can somebody name some databases that appear in your IT systems and your business systems? SQL? Yeah. Any other ones? Oracle? Yeah, so there are those and a lot of other systems. There's a whole basket of different types of databases that are specialized to working with your HR system, your employee database, your POs, like all of that. And it works in tables really well.
And then operational data tends to be quite a bit different than these other 2 types of data. Right? So a lot of times operations, we think of time series, right? And I'm sure you've heard that term 1,000 times already today. But time series data is going to be a value with an associated timestamp. Right? So it's a little bit different than the other two types of data in that it's coming in very, very high volumes and also very high velocities. Right? So a little bit of difference there.
Yeah. And then big data, I'm generalizing here, but tends to go towards an unstructured approach, where in order to be able to combine this data together from these three corners and ask new questions, you kind of have to remove the structure and be able to lump it together in like a data lake or a data warehouse. I mean, even the sound of a data lake, we've unstructured how the data works together, but we can get it all together. That works for the type of questions that you might be asking with that, with a data scientist, but the structure was there in the first place to do a specialized task. Okay, let's look at time and tables. All right.
Yes, so why is time series data so difficult to work with? Right, let's look at a quick example here. On the left-hand side, we've got a few different data streams from a couple of wind turbines. Right, you can see the data is coming in from different sensors at different frequencies. You can see some data gaps. It's difficult to store this time series data in a relational database, in a relational type format. Right? Periods of communication failure, different sensors coming on at different times, uneven spacing, right? How do I represent high fidelity time series data if things are coming in at different frequencies? Spikes out of range, an additional measurement, an additional sensor on one turbine. So you can see that there's many, many challenges with time series data, right? How do we capture all of this data and store it in one spot? Well, luckily, the PI system is really good at handling that time series data on the left-hand side of this display. The PI system is not a relational database, but we've really been built from the ground up to handle time series data streams.
Yeah, we've been designed around that, and what I'd say is, like, you can get the job done in a table, like you could, but there'd be a lot of challenges with it, and you would lose a lot of fidelity of the data that I think you would want to have, or performance would take a hit. That's just what we see all the time, and it's why we built the PI system to be designed around being a time index database in its core and how it actually stores data. Okay, so this is a bit, what you're seeing so far is a bit about, like, okay, why is the PI system built the way it's built? Well, what is it used for? Why is it built the way it's built? I'm going to try to, like, demystify a bit of, like, how is it actually put together and how would a site or a facility use the PI system? So this is a basic PI system infrastructure. This is PI 101 basic PI system infrastructure. On the left-hand side, you see those are parts of your facility. They're assets, they're machines, they're whatever it is you have that's producing data. They send data and they share it to I'm calling it a data system here. Maybe it's a control system or a gateway device that's collecting data. But you have different ways of collecting data already, but it's kept in a couple different locations, different data systems. Now there's people over there on the right-hand side who want to use the data. They have uses they want to do with it. And what they have to do now is they have to go to data system A and copy out some and put it somewhere, and then go to data system B and find what they want and copy it out and paste them together in a spreadsheet and work with it the way they need to work with it. Then they've finally finished their task. What people do with the PI system is we put in a set of PI connectors or PI interfaces. So you're going to hear the term PI connectors and PI interfaces. That's a term for the OSIsoft software written to read from those data sources and pull in the data. So their only job is just to pull in data. Those PI connectors and PI interfaces then collect the data and they move it over to a server that's usually held on site. So there's a PI server that's installed on a machine, and that machine is usually, our customers usually prefer to have that on premises. So there's usually a single PI server on premises, and there's multiple PI connectors and PI interfaces collecting whatever data you want to collect. And it can be connected to all of your assets. And then that PI server distributes the data out to the people that are going to use it in the form of a graph on your phone or a spreadsheet on your desktop or a chart on your tablet. Whatever it is that you want to see it, they're sent out in that way.
And so now we've got kind of like a one-stop shop for all of the people on the right-hand side of this display to access all of their operational data. right? They no longer have to go to system A, system B, system C, try to piece things together. The PI system acts as that one source of the truth for all of the data, regardless of what data system it came from.
Yeah. Now, what would it actually look like? So if one of these people were to be using one of these screens, it might look like something like this. This is a possible screen using PI Vision. So what we see on here is that there's a picture of a tank. So this is probably about a tank asset of some sort. There's a chart against time. There's bar graphs. There's radio gauges. Now, remember, this is one picture of what it could look like. You can rearrange. You can build these yourself. You drag data onto the dashboard. You can configure it the way you want it, move it where you need it to. And I could show you 100 or 1,000 different displays built by different people for different uses. Because that's why we design it the way it is so that it can be used for many different uses. And this is one way it might look. Anything you want to note about that?
No, I think you hit it pretty well. You'll notice that, like in the lower left, we've got total daily production. Right? So I might be interested in looking at the total production for this tank. Right? That's a very simple type of analytic. But in the center, you can dive into the nitty-gritty details around the temperature, the pressure, the level of this tank, right? And try to identify what's going on during my different batches.
Yeah. Now, what would this look like if what we saw here was one site? So this is what the PI system would look like at one site, one facility. For some customers and many customers, this is what they do, and that's it. But if you were operating an enterprise, and by an enterprise I mean a company that owns a number of different sites that perhaps do similar things. Let's say you have 4 different facilities that all do, they do related processes, the same process, but they're all a bit different. They were acquired at different years. They have different control systems, but you want to compare them now. Well, they could each have their own local PI server, and then often that PI server can send summarized data, or all the data if you wanted it to be that, to a office PI server, perhaps at a headquarters or an onshore site, that people in that office can then work with the data as well. And this is something we see very often. It's one of the things that we really pride ourselves at OSIsoft is we built a system that can scale up to work for an enterprise that wants to bring together data from a lot of different places.
So now instead of looking at production of a single tank or a single facility, I can look at what's my total production across all of my facilities, right? Start answering some of those bigger questions.
Yep. And one thing I'll point out, one thing that's very important to a lot of people, so I'm going to point it out here, is if we often are very concerned with, we don't want the people that are working with all the data, like you got a lot of people on staff, you don't want all of them going to the control network to get the data out. Like that isn't a great idea. So one of the things the PI system allows you to do is build a data infrastructure that allows you to get all the data out of the control network and available to anybody that wants to use it without exposing access to the control network or the machines that you have down there. And that works from this scale all the way up to this scale. These people have access to all the data, but they don't actually have access to the sensitive control network. Okay, so I can tell by looking in your eyes. You're all like rearing to go with this. You're like, I want it. How do I put the PI system in? And maybe you've had experience with other enterprise software where it's like, it sounds great and it does amazing things, but then it takes 6 months to put in. And afterwards you're like, this takes forever, and I don't even know if it takes so much. It takes a lot to put in and get running. And you wonder, is that going to be what the PI system is like? We often have a field service engineer go on site and configure, install all the basic parts of the PI system within a week, within a few days, and get data actually flowing. And we're going to go through the steps that actually build up a PI system now. So how to set up a working PI system, the 3 steps to setting up a working PI system.
Starting with step 0.
All right.
And that is to ask the question, what am I trying to solve? Right. So Stuart, let's say you're a brewmaster and you brew beer.
Okay.
What types of problems are you trying to solve?
I like this fantasy. I would be concerned with, I have a tank of beer that I want to cool down, and I do cool it down, but it always takes longer than I think it will. And I would like to, I don't know why, but I need to investigate it because my process is taking longer. It's costing me something, yeah.
So it sounds like we probably need to collect data coming from that tank. right? And capture things like temperature, level, pressure.
Yeah, there's a few temperature sensors on it. We could collect the data from there, and then I suppose, could we chart it? Would that work?
Yeah, perfect.
Okay.
You can trend stuff.
Yeah, and that's the kind of simple process problem you might be looking at solving. And actually, in session 3, they'll look at exactly that, the process that the Schutz went through in using the PI system, both a very basic one and a more advanced one for process optimization. That's in session 3 today in this track. So OK, we've identified what we want to solve, faster cooling of the tank. The first step is, let's install a PI interface or PI connector. So you see there on the left-hand side, you have a data source. You have people that you want to get the data. The first step is, you need to put in a PI connector or PI interface. A PI connector or PI interface is a piece of software written by OSIsoft that installs on a Windows operating system. It could be any box that runs Windows operating system, nothing special about it. And its only job is just collect data from the data source and get it ready and buffer it and make sure that data is available to send on to the next step.
Yep. And so the second step is installing the PI server. Right? And so this is where the data is actually being stored and aggregated and historized. Right? This is what we've been doing for a really long time, is collecting all that time series data. Right? And this is typically installed on more of a server type machine, so a Windows server type operating system, a little bit beefier than the interface node because it's actually going to be holding all that data in and allowing connections to extract the data out.
Yeah. A customer on site might have one PI server and a whole collection of PI interfaces, possibly. And they'll be on separate machines, usually. And then step 3, how do you actually see the data? So this is where you have whatever device is in your hand now, or a laptop. You can show data on that using PI client software. Now, PI client software is an umbrella term for a variety of pieces of software we make that show data. And that's all they're intended to do, is just to show data. That's what they do. And we saw a picture of that before. So these are the 3 steps to configuring a PI system. And really, with these 3 steps, you can be showing data. It's not more complicated than that, right? Yeah. OK. We wanted to take a few questions. So we covered what we think you want to know for PI 101 and the basics. You might want to know some other ones. So what I'm going to put up here is the next question. Oh, can I unfull screen it? Yes. No, not that. Oh, I don't know if I'm going to get it. I don't have it configured right. I have to go to the polls. Well, we wanted to know what questions you have for PI System 101. If you raise your hand, we'll be able to bring a microphone to you. You can do that. In the meantime, I'm going to try to get a ability for you to type in a question configured. Give me one moment. There we go.
Any questions? Oh, you get it working?
I think so. Yep, I did get it working. So on that same place, that same location, pollev.com/StuartC, you can type in a question. And if you don't want to type in questions, you can just look at what other people type in and upvote or downvote it. And then we can see what questions you might have. So whatever question you have about the PI system, just the basics of the PI system, let us know. And we'll try to address it right here. But while we wait for that to come in, I'm just going to review what we went over. What the PI system is used for, it's used across industry. It's used by every industry that you see here. They all use the same bits, the same PI system. There's 6 different general categories for what it's used for. There's a whole variety of users that use it. There's 3 basic steps to configuring a PI system. Data collection with a PI interface or PI connector, storing it with the PI server, and distributing it with the delivery layer, which is PI Vision and Datalink. OK, let's take a couple questions.
Yeah, so the most popular question, how are you filling in the missing data?
How are you filling the missing data? What do you suppose they're referring to there?
So I think that's from the time series data is difficult. How do you put it into a relational type format?
Some data is missing, right?
Yeah.
So how are you making up for that missing data?
Yeah, so the PI system itself isn't going to be able to accurately predict or just shove data in if something's missing. But we have different mechanisms for preventing data loss. So everything from high availability down to buffering from our interface nodes, right? So we're built and designed to capture time series data, which means if there's network interruptions or connectivity issues, between the interface and the Pi server, we're going to limit the amount of data, if any data, that gets lost during that translation.
It is actually missing.
Yep.
If the sensor did not record the data, it never got recorded. What we were referring to there is the highest fidelity can be stored in a time series database like ours. If you transferred it to a table, you might have to wash out some of the fidelity. And usually, folks aren't interested in that. Do you have a Pi server on site, or can it be in Azure? It can be hosted in a VM. Most of our customers want it on site for their own, because they want to keep the data close to themselves. But many people keep it in a VM. And I believe it's also been run in Azure as well.
Yep.
OK. How to extract Pi data in various analytics software? That's a great question. How would you? So if you come to session 3, we'll go more into depth in this. So session 3 of Pi 101 track, we'll go into more into depth to that. The short answer is we have a set of software called the Pi Integrator Suite. And what that software is designed to do is to read data from the Pi system and move it en masse to Tableau, Spotfire, SQL, the Azure Machine Learning to move data where it needs to go.
Yep.
Hadoop or otherwise. New to the Pi system, have Pi at our facility. Where should I start? Core site, process book, one process first? What would you start with?
Yeah, so again, I think that kind of goes to defining what you're trying to solve. Right? So we have a number of visualization tools. You've seen a lot of core site now called Vision, which is the web trending. There's also Pi Datalink, right? So that's more or less building reports within Excel. So it kind of depends on the situation. Pi Vision is more or less our flagship visualization tool. And you'll see a lot of development work continuing to come out of that one as far as creating like web-based dashboards. But if I'm trying to build out a report, I would potentially use Pi Datalink to do that.
And Pi Datalink and Pi Vision are the out-of-the-box tools that come with the Pi system. We support them. We configure them. We make sure that they work with all new versions of software that comes out. So that we know that they'll work really well with the Pi system. They're both great places to start. Adding data that was generated before the Pi system was installed. That's a great question. So I've been using something else for a long time, and I have data in it. Now I have the Pi system. I'd like to get data into the Pi system. Can I do that? And the answer is yes.
So that's a pretty common task for our field service engineers. So the same people that come on site to install the Pi system, they can also come on site to take data from a previous system and get it into Pi. Right? And that process depends on the back end of the system. But that's a pretty common thing that our field service people do.
How much does the cheapest Pi system cost? Is there a free online version to try before I buy? There's not a free online version to try before you buy, and any pricing questions should definitely be directed to your account manager. They're the only person at OSIsoft that can really talk about that subject, but they were happy to do that. Which one would you like to take? What is Pi AF?
Pi AF. So the next 2 sessions are going to be more or less deeper dives into Pi AF. Right? So we talked about how the Pi system is used for storing time series data. Pi AF is really about adding context to that time series data. Right? So I have a data stream coming in. AF lets me say, oh, that data stream is coming from pump number 1. Pump number 1 also has a temperature, speed, a torque, and it also has a last maintenance date. Right? So Asset Framework allows you to add contextual data to that raw time series data that's coming in.
One thing that allows you to do is, we often talk about the scale limits technically of a database, like it won't be able to handle a terabyte, oh no, and we eventually handle that. Well, there's another scale problem when you're building up a data infrastructure, which is the human scale. At one point, Clark and his 5 pumps, he could just handle that. He knew everything about them, and he knew about all the data just by look and feel. But when he now wants to share data with me, or wants to bring me on, or wants to compare data with me, I don't know what his pumps are. I don't know how the data is configured. But AF allows him to represent it in a way that he can share with me that I can understand and get and compare to my own stuff. And again, yeah, the later sessions you're going to see a bigger picture of AF. Let's take 2 more questions, and then we'll be finished here.
All right.
Can you do calculations with the data?
Yes, so that's a great question. And we'll go into some more details again in the next sessions around calculations with the Pi system data. But sticking with that example of a pump, let's say I've got the delta pressure across the pump, and my pump has a rated horsepower. I could theoretically calculate the efficiency of that pump, right? And that calculation I could actually store as a piece of time series data, right? So now I can graph the efficiency of my pump over time, right? And that's just one type of analysis or simple analysis with the PI system.
Okay. Okay, and how do you handle redundancy? How would you handle redundancy? What we showed you here was a very simple architecture, meant because we wanted you to be able to just understand what it was. But often we're concerned with, well, if there's a power outage and a PI server goes out and I can't get to the data, that's a problem. Is there a way for it to have redundant nodes so I can get to the data no matter what? Yes, so there's ways of setting up, we call it high availability is a term for it. It's where we have two twin servers that communicate with each other, and if one goes down, the other one's available to serve data. Similarly, with the way we collect data, you can set up two twin collection devices, and if one goes down, the other one is able to send data. So that's how we handle redundancy. We won't cover that in depth in the PI 101 track, but if you're interested in that, come find us. We can direct you to the right people. I think there might even be a booth section about it. Just about anybody in the booth area from OSIsoft can answer your questions about high availability. All right. I love these questions, and what we'll do is we'll collect these. We'll go through. We'll give you short answers to these, and if you stick around for later sessions, we'll probably be able to address some more of these. And if you really want to know the answer right now, you can come up to the stage. But what we're going to go to is a break right now, because we're on break, and then the next session starts. These are all half-hour sessions. I know they're lightning fast. So thank you very much for coming. My name is Stuart Collins. It's been an honor to have you here.
And Clark Ennis, and feel free to come up and talk with Stuart throughout the rest of the week.
All right. Thank you very much.